Okay, so breakpoint of chlorination. So it consists the zone 1, zone 2, zone 3 and zone 4. So the zone 1, which indicates nothing but the destruction. So you can see that is what the zone 1, okay. So from 0 to a point, so that point indicates the nothing but the oxidation of present compound, that is reducing compounds and inorganics such as Fe, Mn, H2S and NH2 and organics, and converted into chloride ions, so that there is no any residual chlorine is present. Totally applicable chlorine is consumed during this process. So you can see there no any available of chlorine from the point 0 to A. Okay, so up to the next, the second stage, or zone 2, from the point 2 to 3, you can see the formation of chloro-organic compounds and chloramines. Okay, and next zone 3, that is from point 3 to 4, that is the destruction of chloramines and chloroorganic compounds, and zone 4, that is point 4, that indicates the break point, that is the formation of free residual chlorine. Okay, so you can see that is the between point 1 and 2, the water reacts with reducing compounds in the water such as hydrogen sulfide, and these compounds use up the chlorine, producing no chlorine residue. Okay, so what that indicates? That indicates the application of chlorine at the first stage, which totally used for the process of reducing the compounds, okay, hydrogen sulfide and other compounds, and there is no any residue present at the first stage. Okay, so between points 1 and 2. So second, between point 2 and 3, the chlorine reacts with organics and ammonia naturally found in the water, and that is water formation of chloramines. Some combined chlorine residue is formed, that is chloramine. Note that if the chloramines were to be used as a disinfectant agent, more ammonia will be added to the water to react with the chlorine. The process will be stopped at point 3. Okay, so next point, process stops, and using chloramines as a disinfectant agent result in the lethal trichloromethane production, but cause taste and odor problems since chloramines typically gives a swimming pool odor to water. Okay, so next, between point 3 and 4, the chlorine will break down most of the chloramine in the water and actually lowering the chlorine residue. Okay, so that means here the completely treatment of or completely disinfection of water occurs, and finally come to the point 4. So finally the water reaches at the break point, and that point is called as point number 4. That point the point number 4, which showing the break point. Okay, so the water reaches at the breakpoint shown by point 4, and the breakpoint is the point at which the chlorine demand has been totally satisfied. That is totally oxidation of organic matter, totally oxidation of color, odor, taste and other bacteria and organism that going to be killed at the point 4. Okay, so that's why the completely disinfection of water occurs at that point. And if you are going to add excessive chlorine from that point, so that chlorine is act as a free chlorine. Okay, so that is act as a free residual chlorine. So this point, which indicates as a break point of chlorination. Okay, so this point separate the free residual chlorine and chlorine demand. Okay, so that point is called as break point of chlorination. So the break point is the point at which the chlorine demand has been totally satisfied. The chlorine has react with all reducing agent, organics and ammonia in the water. When more chlorine is added past the break point, the chlorine reacts with water and form different types of acids. Okay, so this process known as breakpoint chlorination and is the most common form of chlorination, in which enough chlorine is added to the water to bring it past the breakpoint and to create some free chlorine residue. Okay, so just one of the example, how much amount of chlorine which is required for the treatment of water. Okay, so just consider the basic example. Suppose if you are going to treat water, okay, and the chlorine required for the treatment of water is 0.4 mg per liter. Okay, so if you are going to use 0.4 mg per liter of chlorine dose for a treatment of water, okay, and after addition of that 0.4 mg per liter of dose of chlorine to the water. After 30 minutes, you get the 0.2 mg per liter of the residual chlorine. So how much the chlorine demand? So that is nothing but the chlorine dose minus residual chlorine. How much the chlorine dose? It is 0.4 mg per liter. And how much the chlorine residue? It is 0.2 mg per liter. Okay, so 0.4 minus 0.2, you get 0.2, and that 0.2, it is nothing but the chlorine demand. That much amount of chlorine which required for the complete disinfection of water. Okay, so this is what one of the example which showing how to calculate the chlorine required for the process of water or for the treatment of water. Okay, so for disinfecting water supply, it is required to treat 500 liters, okay, uh, 5 lakh liters. Okay, so for disinfecting water supply, it is required to treat 5 lakh liters of daily supply with 0.5 ppm chlorine. Okay, so how much water we are going to treat? It is a 5 liters water. Okay, 5 liters daily. And how much the chlorine is? 0.5 ppm of the chlorine. That is what the residual chlorine. So if the disinfectant is available in the form of bleaching powder, that means we are going to add bleaching powder for the disinfection process, not it is a free chlorine. Okay, so which contain the 30% of available chlorine. So here is the concentration is given. So into that bleaching powder, how much amount of chlorine is present? 30% of the chlorine is available. Calculate the amount of bleaching powder required to treat the daily flow of water. Okay, so how much amount of bleaching powder is required to treat that much 5 lakh liters of water daily. Okay, so this is what the solution. So from that you can understand how much amount of chlorine is required and how to calculate the chlorine dose or chlorine demand for that water supply. Okay, so 0.5 ppm is nothing but 0.5 mg per liter. Okay, so that is what the dose of chlorine. Then dosage of chlorine is how much? 5 lakh liters into 0.5. Okay, so 0.5 it is the dose of chlorine, and 5 lakh it is what? The water supply into 1 kg per so that is conversion, mg into convert into kg. So the dosage of chlorine is calculated for that particular water supply flow rate. It is 0.25 kg. Okay, so that much water is required. So for the bleaching powder with available chlorine of 30%, so amount of bleaching powder required is 0.25 kg into 130. So it is 0.833 kg. Okay, so 0.833 kg, that much amount of bleaching powder required for the disinfection of that regular flow of water. Okay, so this about the method of disinfection and breakpoint of chlorination. Okay, so breakpoint, it is nothing but a point in the chlorine dose residually curve at which all the destructible chloramines and also the chloroorganic compounds are decomposed and the free residual chlorine begins to appear. Okay, so from that point the chlorine is act as a free residual chlorine. Okay, and thus the chlorination of water can be defined as, or the breakpoint in the chlorination of water is defined as, it is a point on the applied residual chlorine curve at which almost all residual chlorine, it is a free chlorine. Okay, so this process, the chlorination process or the breakpoint of chlorination, having some of the advantage. So what are the advantage of breakpoint of chlorination? First, it remove the taste, that is bad taste and odor of the water. Okay, there is a first advantage, this breakpoint of chlorination which remove the bad taste and odor of the water. Second, the required residual chlorine remains in the water. So after completely disinfection, some residual chlorine present into that water. Next, it helps to remove the organic matter and Mn from that water. Okay, that means is oxidized organic matter as well as Mn. Next, it helps to complete the oxidation of ammonia and other compounds. So whatever amount of ammonia which present into that water and other compound, that also going to be oxidized and reduced in the process of that chlorination. Okay, so these are the some of the advantages of the breakpoint of chlorination. Okay, so this all about the process of the disinfection. Okay, so in this process we discuss all about the different methods of the disinfection, and also we discuss about the chlorination, different forms of the chlorine which apply for the disinfection process, different terms that relate with the chlorination process. Then what is meant by breakpoint of chlorination? Okay, that graph or that curve is showing the breakpoint of chlorination, that is chlorine dose, applied chlorine and residual chlorine, and breakpoint of chlorination. And what are the advantages of this breakpoint of chlorination? We also discuss about the term that is residual chlorine, chlorine demand, chlorine dose, and other terms that like a plain chlorination, superchlorination, dechlorination, rechlorination. So these are all about the process of the chlorination. Okay, so up to that we complete the all treatment process of the water. Okay, that means from the screening of water for removal of floating solid, after the sedimentation process for the removal of suspended solid, then coagulation flocculation for removal of colloidal and dissolved solid. After that the process of the filtration for the removal of bacteria as well as colloidal and dissolved solid, and finally the disinfection, that is a process of chlorination for the killing of bacteria. Okay, that means all process which present in the water treatment plant that we already discussed. Okay, so that means we cover this water treatment flow sheet. Okay, and the different units of this treatment plant. Okay, so now the next topic, it is nothing but the water softening, that is what the extra or additional treatment to the water.